So I think we can start. So good morning, everyone. Thank you for joining and welcome to my talk on launching a substrate-based multi-node network. So may I ask, how many of you have ever heard about the terms multi-chain or cross-chain? Just raise your hands. Who have ever been confused about these terms, about the actual meaning and the differences? All right, so it seems like everyone knows what this kind of stuff means. Oh, this is great, cool. So what we're going to do today is we're going to briefly discuss the idea of a heterogeneous multi-chain, and in the main part we are going to get our hands dirty and explore how to actually set up such a network. Cool, so I would say, let me introduce myself first. So my name is Chris. I have a background in mathematics. I work as a blockchain developer and consultant at SVA. And I volunteer at Chainist mainly as community builder and meetup organizer of the meetup group Crypto Community Minds. All right, so I would say let's start with the motivation. Cool, so this is a picture I found earlier this year, and it demonstrates one thing very well. We are already living in an interconnected blockchain world. And I think, yeah, it's a pretty impressive picture here. So what we can see here is all the major protocols like Ethereum, Avalanche, Polygon, and so on. And the smaller icons here are the actual decentralized applications running on top of these blockchains. So, but still, this is just a glimpse of what is actually going on in the blockchain world. And we can see it when we take a look at Twitter, because the discussions there are, yeah, pretty wild, I would guess. And I brought some examples for you. The first one is about Aave. So this could be a representation of some protocol that follow a multi-chain approach, because what you can see here, all the applications are deployed on Ethereum compatible blockchains. For example, let me take a look here, Polygon, Arbitrum, Optimism, and so on. And just to give you a small definition for this talk here, I would say a multi-chain is a set of interconnected blockchains that are compatible with each other in some specific way. Here's another example, pretty interesting, but there are also protocols out there and projects that try to bridge different blockchains. So here, for example, Zia network, they try to build a bridge between Cosmos and Ethereum compatible chains, and this is pretty interesting since, as you may know, it could be difficult to bridge these assets or to make this kind of bridge thing compatible with another blockchain. So to give you a brief definition here, I would say cross-chain, in this specific talk here, a cross-chain is a set of interconnected multi-chains. And what we can also see here is that Vitalik has some concerns about the cross-chain approach, since he tells, what he expresses is that actually the security regarding these bridges are not that good currently. And maybe you have heard that, I think alone this year, around, I think 2 billion worth in crypto was stolen from these kind of bridges. So there's still a long way to go until this could work. And just to make this thing a little bit more tangible, here we've got 3 different architectures or 3 different, I would say, multi-chain networks. So we've got Avalanche, Polkadot, and Cosmos. And you can just imagine a cross-chain world would look like, just imagine there are some kind of connections between these different blockchain ecosystems. All right, so now comes the question. Why should we use Substrate at all? When we take a look at the official websites, then we can see Substrate is described as blockchain framework for a multi-chain future that enables developers to quickly and easily build future-proof blockchains optimized for any use case. Or in other words, Substrate is an open source framework for building highly customized blockchains. Here, and here are some features. And I find them pretty interesting, as you can see. They follow a totally different approach compared to Ethereum, for example. Instead of building smart contracts and deploying them on top of an existing blockchain, here we can put our logic or our business logic into so-called pallets and build up the runtime with it. And so this is interesting because this enables us to build some kind of, I would say, special purpose blockchains with the logic being an integral part of the blockchain runtime itself. And I think this is pretty amazing. But there are also other features to examine here. For example, we can upgrade the blockchain, what is pretty amazing. And it uses WebAssembly and a programming language Rust for speed and reliability. So I would say I have enough talked, and we can move over to the interesting part, the hands-on part. So what will we going to do? Yeah, here's an example of how our network will look like. No, just kidding. So this is just a telemetry for the Polkadot ecosystem. So all these different flashing dots are actual nodes running outside there. But what we are going to do, we will configure our blockchain in such a way that we will be able to visualize it in a similar way. And our setup looks like this one here. So we're going to set up a free node network with each node running on a geographically separate server. And just to let you know right now, everything you're going to see here is already on my GitHub and in my GitLab account. But of course, no worries. I will share the link to the slides afterwards, so you can take a look afterwards if you want. Cool. So I would say let's jump into GitLab. So here's the project. So this is just something I have copied from a course I have taken last year, but when I first deep dived into Substrate, and I just made some little fixes on the code base, and now we can actually run something with it. So I would say let's take a brief look at the actual code, just to ensure that everyone knows how the application will look like. So you can see a lot of different code stuff here, but the interesting part is down here, because here we can see the methods that will be that we will be able to execute on the blockchain. So there's a create method. This create method generates an NFT called particle in this scenario. We can transfer this NFT to another account. We can set a price, and we can buy an NFT. So I think this is pretty straightforward, and you can see the programming language here is Rust. I don't know if anyone is familiar with Rust. Just I saw, oh, 4 persons already are building with Rust. This is great, cool. Yeah, cool. So this is our application, but this won't be the focus in this talk here. We will focus on the infrastructure part. So I have everything written down in the wiki here. And to launch this special network here we're talking about, we have to go through a 3-step process. First of all, we have to generate key pairs. At the second step, we have to create a chain specification file. And last but not least, we have to start the nodes, obviously. All right, so I would say let's start with the key generation part. Cool, so what do we have to do? I think the step 0, we can skip the step for now. And let's move to the next one. So first of all, we have to create public-private key pairs for the peer-to-peer communication between our Substrate nodes. At the second step, we have to generate a key pair for the Aura consensus. And at the third step, we have to create a key pair for the Grandpa consensus. And you might ask yourself, what does this mean? Do you mean this Aura and Grandpa consensus? Well, I mean, this is all about blockchain things, so everything is about achieving consensus in this whole network. But I have already described it here. In our setup, we will use Aura and grandpa. Aura for creating new blocks and grandpa for the block finalization, just to let you know. All right. So I would say let's execute our first command. First problem here. Why doesn't it work? Oh, I can see the problem. It seems like I haven't waited until it has finished. Oh, all right. So what could go wrong with an hands-on part like this one? Let me try something else. I have created 3 other servers as an emergency plan. So let's open the first one here. Alright, maybe this one will work, hopefully. Alright, no. Alright. But I think that's not a problem, because at the wiki I have summarized the example output. So this is how the output will look like. We will get some kind of 2 different strings. The first one will be the node identifier, and the second one is the private key used for the node itself. And I guess the other, of course, it's all the subkey command. Great, they also won't work. So just imagine that I'm going to copy these different commands here and execute them in the command line. So what the subkey what this command will output is summarized here. So we will get a secret phrase like this one. So I think anyone familiar with MetaMask or Ledger know what this means. This effectively helps to recreate your account again. And you can also see a public key here, and as well you can see the secret seed here. All right, and same holds true for the third step, the generation of the key pass for the grandpa consensus. It's slightly different from the command beforehand, because you can see here a little flag scheme, that just means that we are using another signature type than before. But you can see the output is exactly the same. And this is something we have to do for each node we're using it. And luckily I have already summarized some nodes and keys already here on this page. So I will just show you this in a here. All right, so the first node, I just called it query with the node password query node password. You can see the node key here. So here's the peer identifier, the private key, and you can also see the 2 different keys for the grandpa and the Aura consensus summarized here with the passwords I choose for them. And the same holds true for the other 2 nodes. I just called them Hamilton, and the third one is called Noether. So this is just, yeah, I think a personal trait of me. I just called it, these are just names of famous scientists. And I just think it's a nice way to call the nodes. All right, so let's check the status of our nodes. Okay, they're still running. Yes, just 2 steps ahead. Great, so let's jump back into the overview of our 3-step process. So now you can imagine we have already generated our key pairs. At the second step, we have to create a chain specification file. But for this should be finished. But no worries. We can already take a look at the actual process here. So what we have to do, first of all, we have to export the chain specification that is already installed on our node. So this is just a local chain specification file that you get out of the box when you install the typical node template for Substrate. At the second step, we have to modify these different fields, and we have to enrich different fields with the generated key pairs we did before. And at the third step, we have to convert this JSON file into a file that is readable by the Substrate framework. And we also can take a look of what we are going to do. So first of all, oh, this is great, this has been done. So we can actually take a look at a real JSON file, not just at a wiki. Let's execute the following command and then take a look how the actual file looks like. So hopefully this will work. Let's execute the command in our first node. It seems that this has worked. Let's take a look at the chain specs here. And great, here is the file. So alright, so our typical local network would look like this one. It's just called local network with an ID called local network. No boot nodes are addressed here, no telemetry endpoints. We have a bunch of stuff no one can read of us. But the interesting part comes at the end of the file, because here we can define how the actual authority nodes will be. So we just have to put our public keys of the keys we have generated before to define which nodes are able to create new blocks, and we can do the same for the grandpa consensus. Here we can also put the grandpa public keys just to define which kind of nodes will be enabled to finalize these blocks. And if you may wonder what this number here means, this is just something like a weight, because when you think about blockchains, it's all about voting and achieving consensus. So by putting a 1 to each of these different nodes, we can say that each node in this network is equally weighted. And of course, you can see here some balances of different other public keys. So these are the public keys that are some accounts on our network later. Cool. So I would say that we should modify this file here. So any idea how we could call our node network here? So I will just call it, since we are at code.talks, I will call it code.talks net, for example. Talks, sorry. And let's take an ID code.talks net. Great. So now let's take a look at our wiki again, because here are some interesting things we can just add. So of course we have to define a boot node. So this will be the first node that will actually start the network. And when you can remember the first image when I started with the telemetry visualization, this can be done with this field here. So let's just copy these fields and put them here. And you can already see this one is the peer identifier for our first node. The only thing that is missing is our host IP. So let's check this one. And let's put it here. So now Let's scroll down to the end of the file. And as mentioned before, we have to put all our different public keys of our different nodes in here. And I have already prepared it. And I just have to copy it and put it here. So, great. And of course, we want to add some funds to our different nodes, so they will be able to execute on some transactions. This will be done with this command, with this copy. So cool, that's it. The last thing we need to do, we have to define a sudo palette key, and this is it. So now we have executed the second step of our chain specification process, and we can jump to the last of this last process point here. And here we just have to convert this existing file we have modified here into a substrate readable file. So let me just copy this command here, and let me execute it here. And now we can see, cool, this is the file that can be consumed by the Substrate framework. The beginning looks pretty much the same like the file we have prepared before, but afterwards it looks somehow different, and you can't see the balances anymore down here. Alright, so now we can imagine, unfortunately, this is a non-deterministic process, so it's not possible to do it on all the other nodes. That means that we have to share this chain specification file with all our other nodes. So let's do this by with a git command. Yes, so this is here. I hope I'm in the right branch. Yes, I'm in the demo branch. So get at this specific file. And let's push it to Git. And let's perform a git pull in the other two nodes. Oh, this is great. So this worked. Now we have also this file on our other nodes. And that means that we've done through two of our three steps here. So we have generated some key pairs for our nodes. We have created a chain specification file and shared it with all other nodes. Now in the last step, we just have to start the nodes. And to make it not that boring, I have already prepared the files. But if you want to do it by your own, you have just to copy some template files I have prepared before into a specific folder. It's probably a good idea to rename these files, and after that you have to modify the files according to the generated key pairs. And at the last step, you just have to run all these different scripts. So let's take a brief look at these specific scripts. And wait a sec, they are here. So we'll just open the first one and the already prepared one. And let's put it right, maybe, if it's still readable afterwards. No, not really. So let's just compare them this way, so you can see this is the template file. So you have to choose a node ID. I just chose node 1, node 01, and down here you have to add some kind of secret seeds, some passwords, and so on, and also for the grandpa consensus mechanism. And this is already done here. And same holds true for the other script. So I have enriched this file with a password and a node key. And of course, I just called it node 01. Great, cool. So hopefully we've done everything right. Now we should be able to start our first node. Okay, this looks pretty good, I think. You can see this first node tries to create some new blocks and tries to finalize the blocks, but it's not possible because, of course, the chain specification file defined a 3-node network, and this is just one node. And of course, with a minority of the votes, this node is not able to create blocks or to finalize blocks. So we have also to start to the other 2 nodes. So let's execute the 2 scripts we have prepared. And let's do the same for the 3rd node. All right, so this is awesome. Now we can actually see we have imported block number 6 and 7 and 8, and we have already finalized the first 4 blocks and even the first 7 blocks here. So this is awesome, and there's a nice application out there that can actually make it more user-friendly or visualize it more user-friendly. It's the Polka.js app. Let's take a look here. Because with this app, we will also be able to execute some commands on our network. So this is obviously the Polkadot network. Let's switch to our local network or our code.talks network. Test network development here. And this is port number 9945. Just haven't showed it before, so here I've defined some ports beforehand, but you can also find everything regarding the ports in the README file. Cool, great. So you can see, we can see our recent created blocks, and this app has some other interesting features. But first of all, let me check the settings, because we have to, of course, we have to put a JSON file here that describes our structure of our NFT. This is something I have also placed at the README file here. So it's pretty simple. You can see, all right, this is our NFT. So the structure is pretty simple. We have got a state. I just call it state, but it's simply a hash. And we've got other, let's call it overhead. So let's put it here. Let's save it. And I've realized that we have to refresh this page afterwards, because sometimes it doesn't work if we don't refresh it. Great, so we have saved it, and now we should be able to execute some commands. So let's take Alice, and here are the actual pallets that are running on our network, and here's the particles palette with our code we have seen at the beginning of my presentation. So we can buy, create NFTs, transfer NFTs, and we can change the price. So let's try this one. And great, let's create it. We can sign the transaction. Everything went well. This is great. And now we can see at the recent events that we have created an NFT with the structure state and this hash. And by the account Alice, and the particle index or the NFT index is just 0. So I think let's just try some other commands here. First of all, maybe let's create another one. And maybe let's set a price. So that would mean that we can actually sell it to someone. Let's take the first one. And let's take a price of 10. Now we should Now this should be also here the recent events, right? So a new particle was created, and we have updated the price of this specific particle here to the unit of 10. And now, for example, Bob is able to buy this specific NFT. So let's say, all right, Bob is able to pay, for example, 15 of the specific unit for this NFT. So now he wants to submit this transaction. Everything went well, and now we can see that what actually happened. So some balances was transferred from Bob to Alice, and this is 10. So this is the price of the NFT that Alice has selected for it. And we can see that the particle was sold from Alice to Bob. Cool. So now we come to the last part of my demonstration, the telemetry part. What is really exciting, in my opinion, is that we can take a look at the actual map where all the nodes are. So we just have to search for our network we have created here. So let's search for code.talks. So here it is. Now we can also see our different nodes here and how we named them at the beginning. So we see Noether, Curie, and Hamilton. They are placed in London, Amsterdam, and Frankfurt. You also can see some specific details like the propagation time here. So you can see that the propagation time is between, I would guess, 23 milliseconds here, 50 milliseconds. Yeah, so pretty fast for a blockchain network. And what else could I show? Yeah, this part here. So this is really interesting because now we can see the map, the world map, and we can see our 3 nodes doing stuff here. And when we scroll over these different nodes, we can also see some metadata, so how it's called, at which block this specific node is, and the same holds true for the other 2 nodes. So, cool, I would say. Let's go to my slides again. So that's it. Here you can find the sources, and like I mentioned at the beginning, here's also the link to the slides that you can see here. So thank you a lot.